Okay, here we are in section 6.3. That's permutations with repetitions. There's a formula given to you on page 197. And what it states is that if you have repetitions or repeating letters or repeating selections, when you want to find a permutation of that, you simply take the factorial of the total and you divide it by any factorials that have repetitions in them. So if a letter has a repetition, 3 repetitions of it, you would use 3 factorial. If it has 1 repetition or 2 repetitions of it, pardon me, then you would use 2 factorial. So I'm going to do a real simple example to show you what I mean here in A. In how many ways can Robert be arranged? Okay, so we're arranging Robert, which is 6 letters. So our formula would then say 6 factorial, 6 letters arranged. Any repeats? Well, R repeats, so that'd be over 2 factorial. Nothing else repeats. The O, E, and T, and B do not repeat, so that we don't have to do anything else other than that. So our factorials would be 6 factorial. That's 720 divided by 2. Because 2 factorial is 2 times 1. So that would be 360 ways. So that's how you do factorials with repetition. Now, sometimes you have to be a little bit careful when you're doing factorials with restrictions in them. And it might only have repetition, but it also has restriction. So I'm going to show you an example of that here in the next one. In how many ways can Twitter be arranged if the letters, they must start with W? Well, if you start with a W, you can take that out, and there's only one choice, so that's a 1. Then you have to think, how many ways, how many other things can I take out of there? Well, what's left if I take the W out? Well, if I take the W out, I have 1, 2, 3, 4, 5, 6 letters left. So then it would be 6 factorial over any repetitions. Well, the T repeats 3 times. So it would be 6 factorial over 3 factorial. And that would give us our permutations that we could get if it started with W. So, again, we took the W right out. So we're dealing with, instead of 7, we're dealing with 6, because we take it right out of there because we used it right there. Okay, so let's do that then. 6 factorial, 720 divided by 3 factorial, 6, that's 120 ways. Okay, now, what about if I said starting with the T? Well, no different. If we take a T out there, okay, and you have to arrange these permutations such that if we take the T out, how many letters are we removing from the possible permutations that we have? We're removing 3 letters. So we still have a T there, but we're removing 3 letters from our possible permutations. That leaves us with 1, 2, 3, 4 letters that we can permutate in the rest of our ways. Okay, we want to take out those letters, and we want to arrange the other 4 letters in a particular way. Okay, so there's 4 letters that we can arrange, and none of those 4 letters repeat. So there's nothing underneath. Okay, so if none of those 4 letters repeat, we just leave it as 4 factorial. So that's going to give us our answer at, we do the factorial multiplying, 24. Okay, so that's some examples of permutations or repetitions. We've got a couple more, I think, on the other side here. Okay, let me just check my field of view and timing here. Okay, so it says, in how many ways can 3 yellow marbles, 7 blue marbles, 3 green marbles, and 4 red marbles be arranged in a row? Well, we're wanting to put them in a permutation. What's our total number of marbles that we have? Well, we have, let's go, 3 and 7 is 10, and 3 more is 13, and 4 more is 17 marbles. 17p. Now how many, or sorry, not 17p, 17 factorial. Getting a little off track there. And now we have to do all the repetitions. Well, 3 factorial for the yellow marbles, 7 factorial for the blue, 3 factorial for the green, and 4 factorial for the red. So this is going to probably be a large number. So what I'm going to do is, it's a large number on the very top. I'm going to work the bottom out so that I can divide out the large number by the bottom. So the large number on top is 3.5568 times 10 to the 14. And there's some more numbers, which I'm not going to round off till the very end. I'm just going to leave it on my calculator. But we're going to do what 3 factorial and so forth are. So 3 factorial, you know that's 6. 6, 6. And 4 factorial, we know that that is 24. And 7 factorial we have to figure out at the end. 5,040. So I'm going to multiply out the bottom so that I can divide it into that. So here's how I'm going to do that. I'm going to take that times 24 times 6 times 6. And I've got, for my bottom number, an answer of 4354560. And what I'm going to do then is I'm going to take this number, I'm going to go 7 factorial, leave it on my calculator, and divide by my number on the bottom so that I can get an answer that is 81681600 for our total answer. So that's how you work out that one. Okay, continuing on here, let's just make sure my field of view is okay. How many 4-digit numbers can be made from 2, 2, 7, and 8? Well, if you're only using them once, well, that's 4 factorial. And you can repeat the 2 factorial. So 4 factorial is 24 over 2, which is 12. Black checkers and red checkers are arranged in a line. How many possibilities are there? Well, what's our total? We have 24 checkers arranged, 12 factorial over 12 factorial. So I'm going to plug this one directly into the old calculator. I'm going to go 24 factorial. It's going to be a big number. Divide by 12 factorial. And then I'm going to divide again by 12 factorial. And I get 2704156, or if you like, 2,704,156. And that gives us, or finishes off our permutations examples. Again, permutations, if you remember, with repetitions is this section, and the last section we did with no repetitions. In our next section, we're going to look at ring and circle permutations.